Hello everyone, welcome back to the channel. So today we will be solving this question called the colorful table from the Codeforces. So it was the third question from this code turn round, which was held a long back ago. So yes, we are given two integers n and k. So before proceeding with the question and the solution, I recommend you to solve this question on your own. Okay, not solve, try this question on your own. Try to solve it, and if you are not able to do, here's the solution. So this is a really nice problem, I would say. You should definitely try it on your own. So if okay, you are given two integers n and k, you are also given an array of integers a1, a2, so on up to an of size n. So it is known that for all 1 less than or equal to I less than or equal to n, 1 is less than or equal to ai less than or equal to k. So k will be the value given in the input. So yes, and define a two-dimensional array B of size n cross n as follows. So Bij is a minimum of ai comma aj. So represent array B as a square where the upper left cell is B11 and rows are numbered from top to bottom from 1 to n. Columns are numbered from left to right 1 to n. So that's the standard type of notation. And for each color 1 to k, we have to find the smallest rectangle in which the array B containing all cells of this color. So output the sum of the width and the height of this rectangle. So that's basically the half of the perimeter. Yes, let us take a look at the sample test cases. What do they say? So let me clearly distinguish them. Right. And what about the solutions or the output? Yes. And this is the output. So considering this first test case, so n is equal to 2 and k is equal to 1, and we are given two different numbers. So a1 is 2 and a2 is 2. So basically we will be forming matrix B of size 2 cross 2. So b12, b missing something, no, b21, b22. So that's the thing. And b11 will be minimum of a1 comma a1. b12 will be minimum of a1 comma a2. b21 will also be the same thing, and b22 will be minimum of a2 comma a2. So basically what you are noticing is that so all the diagonal elements are directly the entries from the array, right? So basically this is our matrix B. Okay, and what I can notice here is that so basically b21 and b12 is also 1. So for this test case, for color k is equal to 1, size of the rectangle fitting this 1, all consisting of all the colors A or 1, not A, is basically 2 plus 2. So half of the perimeter is 4. So that is basically our answer. And you can verify it for this test case also. Oh, okay, let's do that. Let's do that. And so here colors are up to 1 to 5, k is up to 5, k is 5, and our grid is like 3 cross 3 where diagonal entries are directly the entries from the given vector. And yes, what I can notice is that, so if I draw, wait, so if I draw this line from 3, if I draw this line from 2, so at this intersection point there will be 2, right? Because 2 is minimum between 2 and 3. What about this intersection point? It will also be 2. What about this intersection point? So it will be 2. So basically these lines will be coming from 4. Okay, and yes, here also it will be 2. Here it will be 3. Okay, here it will be 3, as minimum of 3 and 4 is 3, and here also it will be 3. Okay, so here for k is equal to 1, there is no any cell such that color 1 is there, so that's why answer is 0 for that k is equal to 1. Similarly, for k is equal to 5, answer will be 0. For k is equal to 2, we can see that we have to take the whole 3 cross 3 grid to uh, contain all the 2, right? So that's why answer is 6 for 2. Similarly, 6 for 6, 6 for 3, and 2 for this 4, because it is 1 cross 1 grid and 1 plus 1 will be 2. So that is basically the idea of the question. So what I can notice is that my answer my answer for minimum of all the AIs, all the AIs is going to be 2 into n. Do you agree? So basically, wherever this AI be, so let it be the minimum. So suppose this is our grid, square grid. So I don't care here, 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 or here. Okay, so here, here, so on up to here. I don't care where this minimum is located, but I know when I sketch these intersection lines like this, I know whenever they intersect, wherever they intersect, I am going to get that value there. So I am going to get minimum there. Okay. So I will get minimum in this first row. Okay. Somewhere in the first row, I will get minimum in the last row as well. Similarly, I will get the entry of this minimum in this column and in this column as well. So basically, answer for this minimum is going to be 2 into n. Okay. So what about answer of second minimum? Answer for second minimum. Can you think of it? Try to pause the video and guess it, or not guess it, try to reason it. Okay, so answer for second minimum will be into n if minimum is not located on the corner, in the corner. And if it is, okay, so 2 into n minus whatever it is, some, okay, if minimum is not located in the corner, and 2 into n minus 1 if minimum is located in the corner. Okay, so it is not basically 2 into n minus 1 actually. It can be 2 into, what you can say, 2 into n minus 2 or 2 into n minus 3. Because suppose, let's check for this 2 into n minus 1 first. 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n minus 1 first. Okay, so basically, 2 into n min Okay, so suppose my minimum is sitting here. Okay, so my second minimum, let it be Sn. Okay, second minimum. So wherever it is lying, so here, or wherever it is lying. So when I draw this horizontal line from this minimum, okay, when I draw this horizontal line from this minimum, and I draw horizontal line from this guy second minimum, I know that this intersection point is going to hold minimum. Okay, so there is no chance that this guy's second minimum will get its answer as 2 into n, right? So it will get 2 into n minus 1 if only one corner is occupied by this minimum. Okay, one corner is occupied by this minimum. Suppose if this thing is also occupied by minimum, suppose there are two values that are minimum in the array. Okay, so basically frequency of minimum is greater than 1. Then suppose if this is the case, then your answer for second minimum is going to be 2 into n minus 2. Okay, so suppose if here also there is minimum, so here there is minimum, here there is a minimum, here there is a minimum, then your answer is going to be 2 into n minus 3 for second minimum. Okay, right? And that is the key observation here. Okay, so to come up with the code for this solution, I can maintain set. I can maintain set where I can maintain the what I can maintain is that I will maintain the number of column, not number of columns. I will maintain number of column. So number of column which is not filled by the other minimums occur before. Okay. So what do I necessarily mean by this? The other minimums occurred before. So we will iterate over for I is equal to 1 to n. Okay. So we will iterate over all the things, all the minimums of the array. Okay. All the minimums, or what you can say, you will need to sort the array first. So the given vector input. So you have to sort that input and then go from 1 to n and accordingly update the answers related to the k. Okay, so I think this is pretty much the solution that that is necessary to understand the code. So let us take a look at the code. So yes, I am ensuring the one based indexing for by doing this v of 0 dot first by assigning it to the maximum or minimum, whatever arbitrary value it is. And yes, we are taking the input. And why am I storing this value, index of that minimum? Because we want to erase it from our set, right? So that is basically the thing. And yes, first of all, in the beginning, S will contain the number of all the columns, right? And initializing our vector answer with the 0. And yes, long iterator is equal to star s dot begin, and long iterator 1 is equal to star s dot r begin. So what I'm doing basically is that I am checking the leftmost corner. Okay, so basically I'm trying to check this leftmost corner where till where my minimum can propagate. Okay, till where my minimum can propagate. Okay, this grid is, I think I've drawn it small, but anyways, you got the idea, right? So from here till here, suppose maximums are flooded. Okay, not maximums, minimums are flooded, and suppose not till here. Okay, till here maximums are flooded, and suppose not maximums, minimums. So suppose all these positions are minimums, and this position is minimum, and this position is minimum, and this is not filled by the any minimum occurring before our element. Okay, so for the ith value in the array, suppose it occurs somewhere here. Okay, okay, so basically for that it one will be this column. Okay, this column, and it will be this column. Okay, so it doesn't matter that these values appear. I want to take the leftmost column that's available and the rightmost column that's available. And sorry for this not so good diagram, but yeah, okay, I hope idea is clear. And answer of v of I dot first is equal to maximum of answer of v of I dot first and 2 star it 1 minus it plus 1. So this is basically the interval length, or the length of the, what you can say, length of the interval, and erasing the index related to that value, and finally outputting our answer. So yes, that's basically the thing. I hope you enjoyed solving the problem and listening to the solution as well. Thank you for watching the video. Consider liking it and staying subscribed to the channel. And yes, see you again.